day 15 here. Last night didn't go very well. Spent 2 hours and 45 getting to a thing that the leaderboard closed at 45 for. So, yeah, I basically, it was an optimization problem, and so I instinctively went A star, but it it was not the style of optimization problem where you have multiple ways to get to a given state. There's really only one optimal way to get to every state, so A star is overkill. And yeah, it just in general didn't work out well. Looks like my stream is acting weird, but oh well, I don't have time to debug that now. It's time to problem solve. See if I can do better. And yeah, I know I could have the page pulled up and refresh, but oh nice, more int code. Okay. Step. Okay. Wow. Okay. Starting position of the location of the oxygen. Um. Well. Huh. Okay. So this is int code plus maze finding, but maze finding where we don't know what our target is. Okay, this is going to be interesting. I don't know how to do this. All right, well, let's load our int code simulator first. All right, program. Grab our parsing code while we're at it. All right, so input commands are movement instructions. Okay. Problem is, how do I figure out which direction to go? Map. Because I'm going to be paranoid. So it's going to be a coordinate and the response that I got at that coordinate. Right? I'm half tempted to just like randomly wander. Our problem is I can't just. A conventional A star is like a flood fill ish thing. Uh, I guess I could do rig up an A star that knows how to navigate from point to point. To let it retrace its steps better. Huh. Well, we could also go with the dumbest approach that could possibly work, right? Um, let's see. And I think one of my days I had code. Yeah. Okay. Score. So things from map. If it's 0, it's a wall. Value is 1. Oh. Dot. Otherwise, it's target. Okay. If 0 x is our starting point. Why can't I do that? Fine. I can move in directions, and it will have these offsets. I move 1. That will be x, y. I can move south. That positive y. Effectively, well. Actually, my coordinate system doesn't matter, so we'll do conventional top left down. So yeah, that means negatives are top and left. So go north, I move minus. South, I move plus. West, I move minus. Plus. Okay, so those are my directions. Alright, so now I date. The problem is, how do I get a complete enough map to know that I... My problem is I don't know how far I need to go. So I could do an A star to generate a path to a given node. Oh, this is gonna be insane if I actually try to do it this way. Um, Input getter. What is this? Okay, so I'm wondering if I could get away with just kind of wandering around randomly to build up my map. I'm curious to see what this gives me. Let's see, I have to go max value is 4. So hold X, Y is Y. E1. So this will be my navigation. I want to keep track of the old values because under certain commands you don't actually move. I want to be able to put those back. Okay, so let's see here. App Y0. I need to dump this. Cool. And we just see what our map looks like. And hey, nice, it doesn't even work. 0 is not found in the dictionary. 7. Oh. +1. It's a big map. I was hoping it was going to be little enough that I could, like, do it manually. Oof. Um. Oh, wait a second. 0 is... Wait, that's the starting point. That's that. Oh, yeah, and 0 hit a wall. Okay. That's what all the things are till I know what they are. Alright, well, that's probably not going to work. this is actually going to work, is there? I think I've got all the outside edges found. Find the little drone thingy? Oh, there it is. Target. Okay. So now we'll run part 2. Scenario. Of it. My bet is we're going to get a bigger map for part 2. So now we're going to build ourselves a map. Oh, get my headphone cord tangled up. Curious, is this turning out to be an easy one to solve? No, it is not. Is that really no one's got second star yet? Wow. Okay. All right, well, maybe I'm not as far off as I thought I was. Okay, so I don't need any of this stuff anymore. Let's see here. I need my failed part 1 from last night. Some nodes. Come on. So these gonna move node, and let's see here. Nodes have a key and a cost. My key is gonna be all the way around. That's good. Let's see here. And actually, let's just go with cost. Or stuff goes away. I move node. A I lost targets. I need to get like ReSharper all wired up here because then I could do a generate and. Okay, so. Let's see, actions. Actually, or wait, what am I entering? Editing day 13 for? That was weird. Let's just undo that. Here we go, day 15. Stuff. Day 13 changes. Rid of. So this will be X I plus 1. Target cost plus 1. Target stays the same. This one. Because here I don't actually have to keep track of what my path is, though. Who knows? Part 2 is probably going to make me actually keep track. Those are my things. Oh, I got to pass the map through as well. Sure. So this is valid if I can't do that because it exists. Well, it's a whole different problem. Okay, and eat 2. Current cost, estimated cost, cost plus difference between our X and our target X and our Y, our target Y. Long. Um, okay. All this. Okay, so take our data. Look. So gotta make up my own new thing, so I've got to make it a 3. But yeah, because I'll make a 3 passable 2 to start. It's a 3. If it's a target, it's a 2. 1. Map. Starting. Starting point. Okay. Yeah, that works. Cost is 0. Our target at 2. Target is 2. Oh yeah, I forget the map too. Details. My target map. I mean, it does too. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 3, 4, 5. 1, 2, 4, 5. What the? Supposed to be longs. That does better. Not in the correct form. It's awesome. Long. What's not in the correct format? Oh, did I not actually? Oh, yeah. Can't be right, can it? Haha, nice. And I'm only a little bit behind. Okay. Effectively, what is the longest path to a node? Is the question here. Sorry, what is the longest, shortest path to a node? Okay. So this is designed, so basically now we're going to start from our target node. But our estimated cost So effectively, we're not really going for a target here. So a cost and our target point doesn't exist. Okay, so then we're just going to say current cost plus 100 is, whatever. No solution. Then we're going to use the version of this. Gives me some callbacks. That one, not that one, not that one. Yeah, this one. Effectively, this will be the highest. That's not right. Start from there, cost of 0, then we move. Disable part 1 just to make sure I'm following things. Yep, so a 0. Alright, well, let's. That's where I started, I assume, right? Probably. Hmm. Why did it not evaluate anything? One. Okay. That doesn't seem right. Doing my adjacent thing correctly? Adjacent. I guess. Huh. Solve it. Here. Don't understand. How am I not evaluating anything? Okay, I've got a count of 1. I count of 0. What is going on here? Oh, Alright, I'm stupid. Problem is saying, oh, I'm done. I'm not. I just want to always say I'm not complete. That sounds awfully similar to my old value. Not. Haha, I got some points. Sweet. Okay, so I brute force. So effectively, there's two parts to this. There's figure out what the maze looks like, and then there is find the best path through the maze. Um, I yeah. See, what are we at? We're at 30 minutes. It's not the one I'm looking for. Not didn't do horrible. 35. That's partially because. Yeah, but 7 minutes to get the first part is just impressive. I gotta say, the people who are hitting the tops of these things are they are quite good at what they're doing. Um, or they are either very well prepared or they're very very good at this. Anyway, so yeah, today's problem really breaks down into two. Well, part one breaks down into two parts. Figure out what the map looks like, and find the best path to the target. I was a little afraid that we were going to be given effectively an infinite map, um, and hence it was going to be important to find your path to the target and explore the infinite map at the same time, which was concerning to me. Um, oh, that might be interesting. What if I effectively ran the state of the machine was part of my A star nodes? Oh, that would be cool. Well, no, if we had an infinite map, then you couldn't do part two. But anyway, so my colossally stupid solution for the first part of part one, the figure out what the map looks like part one, was literally just run the simulation and randomly move the robot around, and keep track of how many nodes or how many um, tiles I had learned the contents of. And once I had learned the contents of, or once the number of tiles I was learning the contents of quit going up, then I was like, oh, I have a pretty good chance I've got what the whole map is. Then I copied the map out and I did the rest. I did part one, the real part of part one. Where's my key? Uh, the real part of part one via conventional A star maze solver, and then the second part would be a effectively I did a kind of a reverse A star. The A star algorithm that I'm using lets me run some code at the end when I don't or when I complete, even if I don't find a solution. So what I did was I just rigged it up so that it would never find a solution when complete is always zero, and the estimated cost is always high enough that it will just keep going. So effectively, it will explore everything in the map. It will generate a minimum path to everything in the map. That minimum path is the answer to part two, or that the highest minimum path here is that answer to part two. Now, the interesting part here is that let me just move randomly and see what happens. Part for the first half of part one is the same algorithm that I used for nanobots, which was day 23 of 2018, where I basically had an algorithm that would just randomly guess and then home. Like this one, it would randomly guess at a value and then it would try to home in on the best value near it. Um, and then it would randomly guess another value and it would home in on it, and it just kept looking for if every time it got a new best value, it would output to the console. So I just let it run for a couple of minutes, and eventually it gave me a number that worked. For the first half of part one, I basically did the same thing. I randomly fed numbers into the encode bot and kept track of where it was at. And once it was started being over 60, because first I ran it just dumping out the counts and I figured out roughly where it ended. Once it started getting close to that number, I just had to dump out the state of the map at every point. I waited until it paused for a few seconds, copied that map, confirmed that that map had all the edges intact, which it did. So notice how we don't have any open spots at the top or on either edge. Although now that I realize that, I actually way I wrote the code, it will actually fill blank. It will fill hashes in for things that it doesn't know. That might not be a good idea because, like, if it hadn't explored this spot yet, it wouldn't realize that it. I wouldn't have realized that it could have still gone there. But anyway, because of the way part two was done, they had to give us a finite closed map. Um, so I was, although they really could have gotten devious by giving us a bunch of switchbacks or something. But I just effectively got lucky that I could brute force random it. But again, this is a perfect example of how solving problems under a time crunch like this is not necessarily the same as solving problems for future flexibility, maintainability, readability, understandability. Those are lots of things that are much more important in like real world code. But when you're trying to steal points from people who can get these solutions in like 15 minutes, sometimes you got to take a few shortcuts. So yeah, tonight got me stats. Tonight got me 23 more points. Put me at 465. Will that be enough to keep me on the global board? Just barely. I fell. So last night I was in like the 90s. I'm down to 96. So I've really got to do pretty good to. Like last year I was up at the 50s. I don't think that's reachable at this point. I would have to get twice as many points in the second half as I got in the first half. That doesn't sound viable. Um, I'm probably going to be lucky to hold on to 80s and 90s, unless I get a couple of really good days in here. But, at least I don't feel like I generated completely stupid algorithms tonight, as opposed to last night where the algorithm I figured out at the end was so much better than what I was using at the beginning. Just a fundamental approach to the problem was so far off the first. Anyway, that's it for tonight, the 15th, and yeah, we got 10 more days to go. And I guess we'll see how things keep going from here. But hopefully, I can continue getting enough sleep that I can actually keep staying up to do these. I know when I started off, I told myself I wasn't going to do it, but it only took me 2 days to get back into it. So I guess we'll see if I stick with it the month or not. But anyway, it's been fun. Yeah, it's always interesting sets of problems. They do a nice job of storytelling with these. Um, yeah, cool. And yeah, we've kept this encode thing. What is this? The 10th, 11th? No, we're on day 15. This is like the 7th or 8th encode thing, which is the longest we've kept recurring stuff sticking around. We don't normally keep them this long, but it does bring a bit of a thing to it, just insofar as did how well you've set up your input and output management for it, because that's the thing that changes every time. The code is the same every time. It's just how do you feed input and output. With that, I will call it a night, and we'll see what things look like again tomorrow night.